Hello, welcome back to my linked list tutorial. Okay, so I've just added a couple of functions off camera. Size just returns how many elements are stored in the list, and empty returns true if the list is empty. So in the last episode, we made the functions pushback, get, and erase. So that's just 3 functions. However, there are quite a few more functions that we can implement into our linked list. The first function we can add is very similar to pushback, but rather than pushing to the back of the list, we can push onto the front of the list. The first thing to do would be simply to create a new node. I would then go to the first node in the list, and I'd say that its previous node is now pointing at this new node. I would then go to the new node, and I'd say that its next node is the current first node in the list. And finally, I would say that the first node is now the new node. So let's jump into the code and implement this function now. So that is just void push front, and this is going to take one argument, which is just going to be a reference to t called data. So in the function body, the first thing to do is to create a new node. So that's just node is equal to new node, and then pass in data into the arguments. So we now have to point the previous node of the first node to be the new node. So that's just first prev is equal to node. So the next node of the new node is the current first node. So that's node next is equal to first. And now that this new node is at the front of the list, we just have to say first is equal to node, and then just increase the count by 1. So like in the pushback function, we have to make a special case for if the list is empty. So let's just copy and paste that from the pushback function into the push front function. And that's it. That's the push front function complete. So another thing you might want to do would be to insert a node somewhere in the middle of the list. So let's just say we want to insert an element right here between node 1 and node 2. So as per usual, the first step is to create a node pointer to a new node. And then using an iterating node, we have to get to the node just before where we want to insert the new node. We then have to go to the next node after the iterator and say that its previous node is the new node. We then say that the next node of the new node is the current next node of the iterating node. We can then say that the next node after the node that the iterating node is pointing to is the new node. And finally, we just have to set the previous node of the new node to be the iterating node. And this will successfully insert the new node into the list. Okay, so back in the code, the first thing we're going to do is create an empty function called insert. This function is going to take 2 arguments. The first argument is going to be a reference to t called data. And the second argument is going to be an integer to say where in the list we want to insert the new node. So like I said, the first step is to create the new node. So that's just node pointer node is equal to new node, and then pass in the data into the constructor. Okay, so I just zoomed in a bit so it's a bit clearer. Okay, so what we need to do now is just iterate to the node before where we want to insert. So I'm just going to copy and paste this for loop into this function. And then rather than iterating to where, it's going to iterate to where minus 1. And this is simply because where minus 1 would be the previous node where we want to insert. And of course, we need to actually create a node pointer called iter before we can actually iterate to the node. So like I said, the first step is to set the previous node of the next node after the iterator to be pointing to the new node. So that is iter next prev is equal to node. We can then say that the node after the new node is the next node after the iterator. So that is node next is equal to iter next. So we can now deal with the node that the iterator is pointing to. So first of all, let's set its next node to be the new node. So that is just iter next is equal to node. We can then say that the previous node of the new node is the iter. So that's just node prev is equal to iter. We then have to increase the count by 1 because there's a new node. The only problem with this function would be if someone tries to insert the front or the back of the list. And that is simply because you would be dereferencing a null pointer in several places, which would cause a crash. Luckily for us, we already have 2 functions which can handle this for us, the pushback and the push front function. So back in insert, I'm just going to add 2 if statements. If where is equal to 0, then push to the front, and then just pass in the data. Or if where is equal to count minus 1, then push to the back of the list, and then just pass in the data there. I'm just going to clean this up a little bit. And there we have it. So to test this out, I've got my list insert me 5. I have to do insert me because the function takes in a reference to a int rather than just a plain old int, so I just have to do that. And I'm inserting it into location 5. I'm then printing out location 5. So if it all works, it should be printing out 2. And as you can see, it does. It prints out 2. So what I've got here is I've got a function called SumFunction. In this function, I'm creating a linked list called local list. I'm then pushing 10 numbers into this list. And then right here, something happens. The list goes out of scope. The list itself is deleted, but the integers that we pushed into the list are not. Now, this is the infamous memory leak. Now, all this basically means is that owning pointers go out of scope before the objects they are pointing to are deleted. This means that we no longer have any way to access those heap allocated objects. This means that those objects are taking up precious memory that we can no longer use. Now, luckily for us, C++ has something built in called the destructor. And this is just a function which is automatically called when an object goes out of scope. And the idea behind it is that you delete memory that the class owns in this function. So let's implement this now. So the destructor is known because you have a tilde symbol before it and then the class name. So this function here will automatically be called when this object goes out of scope right there. So I'm actually going to make a separate function just before we do the constructor called clear, and this is simply going to delete everything in the list. So all we're going to do in this function is say that while count is not equal to 0, erase 0. And this will erase the first element in the list until it's empty. So in the destructor, I'm just going to call the clear function. And now when this function is called, the local list will go out of scope and it will call this function and all the memory will be deleted and cleared and we will no longer have a memory leak. So to test if the linked list destructor actually works, I've gone into the node struct and I've added a destructor to it. And in this destructor, I'm just printing out deleted node with data. And when I run the program, as you can see, it's deleting all the nodes in this list. In other words, there is no longer a memory leak. Okay, so right here, I have a pretty basic setup. I have a linked list in the global scope called global list, and I've got a linked list in a function called local list. I'm pushing some numbers into the local list, and then I'm saying that global list, this one here, is equal to local list, which is the one we just filled up with numbers. This function is called from the main function, and then I push some more numbers into the global list. I then print out the third element in the global list. And I get a crash. Why is this? The problem is this line of code right here. All this does is it's making the global list share the same elements as the local list. At the end of some function, local list is getting destroyed. And the destructor of the local list is being called, and it's deleting every node in that list. And because we do this, global list is equal to local list, this causes all the nodes in global list to get deleted as well, because they are sharing the same nodes. And so when we try to print out the third element in global list, we are trying to print out the data of a deleted node. This is undefined behavior, and it causes a crash. To solve this issue, we need to do something called overload the assignment copy operator. And the copy assignment operator overload is simply just a function which is automatically called when I say global list is equal to local list. So to make a operator overload for the assignment operator, we just need to say that linked list address of the linked list operator equals, and then in the arguments we need the other linked list. So that's just const linked list address of that other. So if you look at the expression above the function, you can see that global list is equal to local list. Global list will be the one being returned from the function, and local list would be the one passed into the arguments of the function. So what we want to do is we want to copy other into, the linked list. So first of all, we would need to clear any nodes that are currently in the linked list. So we can just call clear for that. And so to copy every element of other, we just need to iterate through all of its elements. So first of all, we need to create a node pointer called iterator, and we need to point this straight to other.first, which is the first element of the other linked list that we are copying from. So to iterate through the linked list, we can just do this in a while loop, and in this while loop, we can say iter next. So iter next is technically a boolean. In other words, it will loop through the linked list until iter next is a null pointer. In other words, it reaches the last element in the list, and thus iter next is false and it breaks out the while loop. In this while loop, the first thing we need to do is push the element at iter into our linked list. So we can just say that push back iter data, and this will push back the data that iter is currently pointing to in the other list. And the last thing to do in this while loop is, as per usual, we just need to say that iter is equal to iter next, and this will iterate the iter through the linked list. And finally, we just need to return this, but dereferenced. So return dereference this. So if this was successful, then doing this should hopefully copy the elements rather than making both lists share the same elements. And this should print out 3. And as you can see, it does, it prints out 3. Which means our copy operator worked. Unfortunately for us, someone might try to call the copy constructor by saying that global list is equal to linked list of integers local list, and this would call the copy constructor, which we have not defined. And like before, we would be getting undefined behavior if we tried to print anything in the global list. So luckily for us, this is pretty easy. We just need to create a usual constructor, so that's just linked list, and in the arguments of this constructor, we just need a const reference to another linked list called other. And then in the body of this constructor, we just need to dereference this and make it equal to other. And this will simply call the copy assignment operator that we just defined before. Unfortunately, you would now get a compiler error. Now, the reason for this is because we explicitly defined a copy constructor, but we have not defined a default constructor. And because we're not passing in a linked list into the constructor arguments here, we're getting a compiler error. So all we need to do is define a default constructor. And because modern C++, this is really easy. We can just say that linked list is equal to default. And this will automatically create a default constructor for us. And so now if we run the program, it prints out 3 like it did before. And this works because we defined the copy constructor. Someone else might come along and try to optimize things a bit by saying that global list is equal to standard move local list. So what this does is it calls something called the move assignment operator. And this is basically a transfer of resources from one object to another. In other words, we want to move all of the nodes in the local list into global list. However, we don't want to copy them over. And because we move the resources from one place to another, we want to destroy the local list in the process. Otherwise, it's pointless because we would be getting undefined behavior when local list goes out of scope, like before. So this looks quite similar to the copy assignment operator. The only difference is we pass an R value reference into it. And so the first thing we need to do is return a linked list reference. And then we just have to say the operator equals. And then in the arguments of this operator overload, we just have to say that linked list ampersand other. And the double ampersand just means we're passing an R value reference of a linked list into this operator overload. So like in the copy assignment, the first thing we need to do is clear any nodes that were currently in this linked list. And so to transfer the resources, all we need to do is say that our first node is equal to the other first node. And then our last node is equal to the other last node. And because we've done that, the number of elements in our linked list is going to be the same as the number of elements in the other linked list. And finally, we just need to essentially reset the other linked list. So we have to say that other first is equal to null pointer, other last is equal to null pointer, and other count is equal to 0. And then finally, we just need to return this. So what we just did there was fairly simple. So the first thing we did is essentially make them share the same nodes, and then we destroyed the other linked list. In other words, we transferred the resources without copying them, which of course is a lot more efficient than calling the copy assignment operator. So the last thing that someone might try and do is call the move constructor on the global list. And that's just another constructor, so we just need to make a constructor, and in the arguments we need to pass an R value reference to a linked list called other. And then essentially we can just say that this, dereference this, is equal to std move other. And that will call the move assignment operator, which we just defined before. And essentially, that's our linked list completed. We have implemented the rule of 5, and we have more general functions for pushing nodes and erasing nodes and that sort of thing. And that's it for this episode. Thank you for watching. In the next episode, we're going to be talking about the big O notation and how it relates to the linked list. So once again, thank you for watching and goodbye.